Hello everyone, myself Sravanthi, working as a assistant professor in the departments of Data Science and Cybersecurity in MLR Institute of Technology. Today our topic is regular expressions. So a regular expression can be defined as a language or a string which are accepted by finite automata. Like finite automata means it's a DFA or NFA. A finite automata consists of generally 5 tuples in number of states, input symbols, transition function, starting state and final state. But coming to the regular expression, only it considers or it depends on the symbols. Symbols are nothing but number of inputs, sigma. It depends on sigma. It will consist only with input alphabets. Regular expressions is written as, in a shortcut we can write it as capital RE. Regular expressions are used to denote regular languages. So the definition of regular expression. Epsilon is a regular expression, indicates the string containing empty string. So here epsilon is nothing but it represents as a empty string. Empty string is nothing but 0. Empty string is nothing but 0. Nothing but null string. The length of the string is 0. The length of the string is 0. It indicates the language containing an empty string. So in the how it can represent is L of E. L is nothing but language. Epsilon is equal to, it can be represented in the form of set. It can be represented in the form of set. Pi is a regular expression denoting an empty language, nothing but empty set. Empty set is nothing but that thing is there. So pi is nothing but empty language. So there is no zero length string, nothing is there. It's empty. X is a regular expression. So in the form of language, how it can represent is L equal to flower bracket X. If X is a regular expression denoting the language L of X, and Y is a regular expression denoting the language L of Y, then X plus Y is nothing but it's a regular expression to the language. How we can represent this X plus Y regular expression in the form of language is L of X union L of Y. L of X union L of I. Nothing but where we can write it as L of X plus Y is equal to L of X union L of Y. So the plus is nothing but here union operation. Plus is nothing but here union operation. Similarly, the concatenation is represented it with dot. Concatenation is represented with dot. X dot Y is a regular expression corresponding to the language L of X dot Y. So how we can write it as L of X dot Y? It can write as L of X, L of Y. L of X, L of Y. So the dot represents nothing but concatenation. So instead of writing XY, XY and X dot Y, both points to same. So R plus is a regular expression corresponding to the language L of R star. L of R star is nothing but L of R star is equal to L of R whole star. So R star is nothing but it's a clean closure. So anything we are going to write it in the form of regular expression, that it can be written in the form of languages L of. So the regular expression examples. So here the language L of 001, we can write it as 001. Just now we have seen L of X is nothing but, L of X is nothing but I can write it in the form of set X. The same way here we can assume these as X. So we are writing it in the form of set. Next, L of 0 plus 10 star is equal to, how we can write it in the form of set. How we are going to write it in the form of set is L of 0 plus 10 star. Plus is nothing but either I can take 0 or 1. 0 or 1. So 0 star. So here 1 should be followed by 0 star. So how we can write these language 0 plus 0 star. So I can write it in the form of one time I am taking 0. Next I am taking 1. And next I am taking 10. I can also take 100 or 000 also can be taken. So how we are going to write here, it is nothing but the plus I can take 0 or 1. 0 I can take 0 or 1. It's like a plus is nothing but it's a union operation. It's a union operation. So how we are going to write it in the form of a set. So 0 star is nothing but it's a closure. So 0 star represents, we can take 0 as 0 or many number of times. Unlike I can read it as 1 time or 2 times or infinite times. So nothing but 0 or more times. So star represents 0 or more times. I can read that symbol. I can read that symbol 0 or more times. So the next one, L of 0 star 1 0 star. So how we can write it? See here, L of 0 star 1 0 star. So here the 1 should be read only one time. Here I can have 0 star. Here I have 0 star. So 0 star is nothing but 0 or more times. How I can write it as? I am going to write in the form of a set. First time I am reading only one I am reading. So the next I am going to read these two, 0 1 0 1, or else I can read these two, 1 0 1 0, or I am going to read this 3 0 1 0, or I am going to have these 0 two times, 0 0 1 0, or I have 1 0 0, or any number of zeros. So this is also a set. So 0 or more times I can read. Star I am having is nothing but I can read this symbol or this input symbol 0 times or more times. 0 is nothing but epsilon times or more times. Here also I have 0 or more times. Initially these two I am considering it as epsilon. So only one I have read. So the next time I am considering only these two symbols. So nothing but 0 1. Next I have considered these two symbols. 1 0 I got. So the next time I consider these three symbols. And next time 0 I am reading more than one time. So nothing but 0 0 1 0. See here, only one time I am reading 1. But zeros are read more than once. So the next one, we can write, see here, that is, if we are writing it in the form of a language, it has exactly a single one. Only one single one I am going to have. See here in the set. The next, L of sigma sigma whole star. Sigma sigma whole star is nothing but, W is nothing but the string consisting of string length even. Here I have the two symbols, two input symbols, and that is of even length. If I take A, B or B, A, whole star I have, whole star. So nothing but A, B, if I have the length in the form of the first sigma is pointing to A, the second sigma is pointing to B is nothing but I can have AB or AB, AB. Or also I can have epsilon also. Star is this. Star is nothing but 0 or more times. Epsilon or AB, 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 so on. So, but what it is the condition? It is having even length. The string is having even length. So, the next one, L of 0 or 0 plus 1 whole star. The star is for whole function I am having. So, whole it is there is nothing but first we are going to get it as epsilon. Nothing but 0 or 0. How can I represent 0? By using epsilon. In the definition we have seen. So, the next time. So, what it is 0 or 0 plus 1 whole star. So, 0 plus 1 whole star. First time I have read epsilon. Epsilon is nothing but 0 times I am reading. So, the next time this, it is in the form of concatenation. So, 0, I am going to read 0. Yes, 0. And the next 0 means nothing but how I am going to read is 0, 0 plus 1 one time is nothing but 0, 0. Here 0 plus 1 is nothing but either 0 or 1. So, I am reading here 0, 0. So, the next time I am going to read it as 0, 1, 0, 1. Next I have 2 times. Nothing but 2 times zeros I am reading. Here also 2 times zeros or 1 time. So, this is the combination. Okay. So, this is the set. Next, 0 plus epsilon, 1 plus epsilon. So, it is in the form of a concatenation. Concatenation is nothing but for how it will be 0 into 1. What I am going to get? 0, 1. And 0 into epsilon. 0 into something is nothing but 0 into empty string. So, 0 into some null string. 0 into null string is nothing but null string. 0 I am going to get. See here, 0 into null string. I am going to have 0. Okay. So, 0 into null string, 0 I am getting. So, next, epsilon into 1, 1 I got. Epsilon into epsilon, epsilon. So, this is the set for the given language. Next, L of 1 pi is equal to pi. 1 pi. Pi is nothing but what? It is a empty, null set. Epsilon is nothing but null string and pi is nothing but empty set. So, nothing but 1 into 0 is nothing but I am getting it as 0. Something into empty is nothing but empty. Next, R into epsilon. R into epsilon is nothing but R is some regular expression and epsilon is some null string. Some null string into regular expression is nothing but I am going to get regular expression. Next, R plus pi. R plus pi is nothing but R is the regular expression and pi is nothing but the null set or empty set. So some regular expression plus null set is nothing but we are going to get it as a regular expression. But coming to the concatenation, we are going to get it as empty set. Next, examples. Some examples we will look into here. Write the regular expression for the language accepting all combination of A's over the set sigma equal to A. See here, we are going to construct a regular expression for the language. The language should accept all the combination of A's over the set, all the combination of A's. So nothing but here I can have epsilon, all combinations. I can have epsilon is also accepted. Next A, 1A is also accepted. Next 2A's, it is also accepted. 3A's, it is accepted. Some 5A's accepted. All the combination of A's. So here how it is in the form of epsilon, one time A, twice, thrice, so on. The A's are going to be repeated. So how we can go into, this is in the form of language. We are going to have, this is in the form of language. So what will be the regular expression for me here? So there are three types of, we have seen star. Star is nothing but it points to 0 or more occurrences. 0 or more occurrences. Plus is nothing but 1 or more occurrences. 1 or more occurrences. So 0 means nothing but here we are going to have epsilon. 1 means there is no epsilon is there. No epsilon here. So how we can write the regular expression for it? A star, right? A star. So how we can write L star? L star is nothing but what I am going to have? Epsilon, comma, epsilon union L power 1 union L power 2 union L power 3 union L power 4, so on. In the same way, here also I am going to have A power 0, A power 1 union A power 2 union A power 3 union A power 4, so on. It's going on. It's an infinite set. Any combination of A's. So if it is in this form, we are going to write it as L star. But here for me the alphabet is A. So the regular expression is A star. The regular expression is A star. Next example. Write the regular expression for the language accepting all combination of A's except the null string. So except the null string. It is not going to accept the null string over the set A. So here first we are going to construct the language. So how it is? Here in the previous example, it's all combination of A's means we are going to have epsilon. But coming to here, it is not going to accept a null string. So null string is nothing but epsilon is not accepted. Epsilon is not going to, it is not accepted. So all combination of A's. Single A, it is accepted. 2 A's, it is accepted. 3 A's, it is accepted. So on. So what is the regular expression for it? What is the regular expression for it? L plus. The regular expression is L plus. L plus is nothing but how we are going to write it is L power 1 union L power 2 union L power 3 union L power 4, so on L power n. So how we can write it here? A plus. The regular expression here we are having is A plus. Why? Because it is not going to accept epsilon. If suppose it accepts epsilon means L power 0. L power 0 is nothing but epsilon. Epsilon is nothing but null string. But here they gave except epsilon. Next, write the regular expression for the language accepting all the string containing any number of A's and B's. Any number of A's and B's. Any number of A's and B's is nothing but, see here, I am going to construct a language containing any number of A's and any number of B's. Epsilon, any number of A's, any number of B's, AB, it is accepted, AAB, it is accepted, any number of A's and B's, BAA, so on. So it is going to accept any number of A's and any number of B's. Just now we have seen only single A combinations and no null string. Here we have any number of A's and any number of B's. So how we are going to write the regular expression for it? So the regular expression we can write here is A plus B whole star. A plus B whole star. So how we are going to write any number of A's or any number of B's? So here it is a union operator. So how we can write this in the form of epsilon? Epsilon, why? Because it is a 0 or more occurrences. A, I can have A, or I can have B, or I can have A's, or I can have B's. I can have B's. So this is the string. Any number of A's and B's. Any number of A's and any number of B's. Next, write the regular expression for the language accepting all the string which are starting with 1 and ending with 0. It is starting with 1 and ending with 0. So how it is? It should start, we are going to have a language that should start with 1 and end with 0. That should start with 1 and end with 0. But in the middle, it's a combination of zeros and ones. Zeros and ones. So nothing but I can have 0 or I can have 1. So I can write the language, how I can write the language is 1 0, it is accepted, 1 0 0, it is accepted, 1 1 0, it is accepted, and next I can have 1 1 0 is also accepted, so on. 1 0 0 is also accepted. So this is different type of language. So what I am going to have the language? So the 1 is fixed and 0 is fixed. But here in the middle, it can be a combination of zeros and ones. So here 1 and 0 are fixed. But in the middle, I can have 1 0 or 1 or anything. Any combination of ones and zeros. So how we can write the regular expression? How we can write the regular expression is 1 and I can have 0 plus 1 whole star 0. Or we can also write it as 1 0 or 1 whole star 0. Or else we can also write it as 1 1 or 0 star 0. Anything. So this is also one regular expression. So the regular expression is this one. Anything, doesn't matter. 0 plus 1 or 0, both points to same. So the next, write the regular expression for the language starting and ending with A and have any combination of B's. Any combination of B's. So nothing but the starting and ending should be A. The starting and ending with A and having any combination of B's. So nothing but I can have any combination of B's. Nothing but 1, 0 or 1, anything. So let us write first the language. So the starting and ending is A. So AA, in the between I should have a B's. So ABA, ABBA is also accepted. Or ABBA is also accepted, so on. Here there is no B, nothing but 0 occurrence. A epsilon A is nothing but AA. So how I can write? The starting is A, ending is A, but in the middle any combination of B's. So that is nothing but the regular expression is A, B star A. Next, write the regular expression for the language accepting all the string which are having exactly 2 B's. So, in my string, in my language, in the strings that should have 2 B's. Exactly 2 B's should be there. So, I can have A, B, A, B. It is also accepted. A, B, A, B, A. It is also accepted. B, A, B. 2 strings. It is also accepted. So on. So, nothing but I should have 2 B's. 2 B's. Compulsory, it is should have exactly 2 B's, but any number of A's can be there. So I can 2 B's, this is accepted, but I have A, B, A. So A, B, A, it is accepted. This string is also accepted. So the next A, B, A, B, A, it is also accepted. B, A, B, B, A, B, it is accepted, right? So A star is nothing but I can read 0 or more times. So once time I just skip it and I can have BB. So this is the regular expression. Regular expression. A star B, A star B, A star. Because it is fixed only, it should have 2 B's. Exactly 2 B's. Thank you.